Welcome to your ultimate pit stop, Piston Pundit, where we delve into the world of electric vehicles and uncover the intricacies often overlooked. EVs are hailed as the future of green transportation, reducing emissions and promising a cleaner planet. But beneath this green veneer lies a range of hidden costs, from the environmental impact of battery production to economic and social implications. Today, we'll reveal 8 key points that showcase the less visible costs of manufacturing electric vehicles. Number 8. Environmental toll of battery mining. Electric vehicles depend on lithium-ion batteries, which need large amounts of raw materials like lithium, cobalt, and nickel. While reducing tailpipe emissions is the focus, the extraction of these materials has significant environmental costs. Mining for lithium and cobalt often occurs in sensitive areas, causing habitat destruction, soil degradation, and water contamination. In the Democratic Republic of Congo, where cobalt is mainly sourced, these practices lead to severe environmental and health issues. Additionally, mining rare earth elements involves toxic chemicals and generates waste, impacting ecosystems and human health. The environmental footprint of battery production is substantial and requires urgent attention as the world shifts to electric vehicles. Number 7. Carbon footprint of battery production. Producing EV batteries isn't as green as it appears. The manufacturing process is energy-intensive, relying heavily on fossil fuels. This results in a considerable carbon footprint that can undermine the environmental benefits of driving an EV. For example, manufacturing a single lithium-ion battery can emit up to 100 kilograms of CO2 per kilowatt-hour of battery capacity. As technology advances and larger battery capacities are required, these emissions can accumulate significantly. The carbon footprint varies based on the region and the energy mix of the manufacturing facility. Addressing the energy sources used in battery production is essential to minimize the overall carbon impact of EVs. Number 6. Economic burden of scaling up production. Scaling up EV manufacturing to meet rising demand presents significant economic challenges. Massive investments in new facilities, technology, and infrastructure are required, leading to increased costs for consumers. Building and maintaining battery production facilities involves substantial financial investments and complex logistics, including securing raw material supplies, managing supply chain disruptions, and ensuring battery quality and safety. These factors can lead to higher EV prices, making them less accessible to the average consumer. Additionally, the economic viability of scaling production is tied to market dynamics and government policies. Subsidies and incentives support the industry but also have broader economic implications. Balancing EV production growth with economic stability is a critical challenge for the automotive sector. Before we delve deeper, do us a favor and smash that like and subscribe button. This helps us reach more auto enthusiasts just like you. Now, let's shift gears and steer towards our next point. Number 5. Energy demands of battery recycling. As EVs become more common, efficient battery recycling is crucial but challenging. Current recycling methods for lithium-ion batteries are complex, energy-intensive, and not fully optimized. They often struggle to recover valuable materials like lithium and cobalt effectively, and the technologies used can be costly, offsetting some environmental benefits. Additionally, battery recycling infrastructure is still developing, causing gaps in collection and processing. To minimize the environmental impact of EV batteries, improving recycling technologies and methods is essential. As the industry grows, investing in advanced recycling solutions and expanding infrastructure will be key to addressing the hidden costs of battery disposal. Number 4. Social and ethical implications of material sourcing. The sourcing of materials for EV batteries raises significant social and ethical concerns. In many cases, mining operations are associated with human rights abuses, including poor working conditions, child labor, and the exploitation of local communities. For example, the Democratic Republic of Congo, a major source of cobalt, has faced severe criticism for its mining practices, which often involves severe labor violations and environmental harm. The lack of oversight and regulation in these regions exacerbates the social issues linked to material sourcing. Addressing these ethical concerns requires a comprehensive approach, including stricter regulations, better transparency in supply chains, and support for fair trade practices. Consumers and manufacturers alike must be aware of the social implications of their choices and advocate for more ethical practices in the sourcing of materials. Number 3. Strain on global supply chains. The surge in electric vehicle demand is straining global supply chains, exposing vulnerabilities in the complex network of suppliers and manufacturers. Key materials like lithium, cobalt, and rare earth elements are concentrated in specific regions, such as South America, the Democratic Republic of Congo, and China, creating significant supply risks, including price volatility and geopolitical tensions. Additionally, the just-in-time manufacturing model can be disrupted by shortages or delays in critical materials, leading to production halts and increased costs. Addressing these challenges requires more resilient and diversified sourcing strategies, increased domestic production capabilities, enhanced transparency, and strategic reserves. A robust and flexible supply chain is crucial for managing the hidden costs of EV manufacturing expansion. Number 2. Impact on traditional automotive jobs. The shift to electric vehicles significantly impacts traditional automotive jobs and the broader workforce. Transitioning from internal combustion engines to electric drivetrains requires new skills, creating demand for technicians and engineers skilled in EV technology. However, this shift may displace workers in traditional roles, like engine assembly and repair, who will need retraining. The effect extends beyond manufacturing to the entire automotive ecosystem, including suppliers, dealerships, and maintenance services. For example, fewer engine maintenance needs for EVs could reduce service-related jobs. Addressing these challenges requires robust support for workforce transitions, including retraining programs and industry education collaboration. Ensuring a smooth shift is vital for economic stability and supporting the growth of the electric vehicle industry. Number 1. Future of sustainable EV manufacturing. As the automotive industry evolves, addressing the hidden costs of EV manufacturing is crucial. Future advancements in technology, materials, and production processes are key to enhancing EV sustainability. Investing in research and development to improve battery tech, recycling methods, and reduce material extraction impacts is essential. Innovations like solid-state batteries and alternative materials could revolutionize the industry. A holistic approach to sustainability, covering the entire life cycle of EVs from production to disposal, is necessary for long-term environmental goals. Collaboration among manufacturers, policymakers, and consumers will drive a more sustainable future for electric vehicles. Acknowledging and tackling these hidden costs will lead to more informed and sustainable practices in the automotive world. Thanks for watching. Don't forget to subscribe to Piston Pundit to stay updated on the latest vehicle news and upcoming videos. See you next time.